isosceles triangle means that your two legs of this triangle have the same length. Okay, hopefully you guys found this pretty easy, pretty straightforward. Roof on a house has one side that is in the shape of an isosceles triangle. The sides of this part of the roof are 18 feet long. Angle at the peak is 50 degrees. Find the area. Okay, so we're staring at a side angle side. There's no need to find any other missing sides or angles. We can jump directly into our rule. 1/2 side times the sine of angle. Okay, what you guys get?
124.
Okay, good. And what's the unit of measure? Good. Area is a two-dimensional unit. Square feet. All right. Actually, let's do number 6 as well. Any questions with 7? Let me draw a diagram for you for number 6 because you may not be as familiar with these geometric shapes that you haven't seen in a while. A rhombus is basically a square on a slant. So your sides are still going to be the same length. It's just the angles are not going to be all perpendicular. Okay, so it says the size of a rhombus is 15 centimeters long and the length of the longer diagonal is 24.6 centimeters. Find the area of the rhombus. Okay, so don't worry about the fact that it's a longer diagonal. We can just choose, make this 24.6. Okay, find the area of the rhombus. Well, I think, what do you think? What's our strategy, you think, for this? What can we? Yeah, make it 2 triangles, right? So let's just go ahead and find the area of one triangle using side, side, side. And once you get that, we can just double it, right? Because they're going to be identical versions. Okay. Okay, so think about the 2 things that we have to gather, right? You got to find the semi-perimeter, and then dump it into the area formula that has the square root. After you get the area of that shaded triangle that I have there, then you can double it to get the area of the rhombus. So I'm just going to focus on the triangle for now, one of the triangles for now. Semi-perimeter, 15 plus 15 plus 24.6 divided by 2. That's going to give me the S value that I need for my area formula. And now we just look at the area formula and replace every S with 27.3. And then our A, B, and C values. It really doesn't matter which order is which, as long as we include them all in our formula. So minus 15, minus 15, minus 24.6. We get the area, but remember, this is only the area of the triangle, right? To get the area of the rhombus, we're going to have to double that triangle area. So I'll multiply this by 2, 211.2 square centimeters. Yes. Oh, I got 212. That's fine. I mean, just it may just be we rounded a little differently. I see. That's fine then. Oh. Okay. Are we good with good review of our area formulas that we just learned yesterday? Give you guys another minute. Okay, so the one that I want us to tackle is on page 26. We'll probably go through most all these problems if we have time, but let me start with 15. So put a star next to 15. That's the one that is most challenging, but you're going to be expected to know how to do on the test. So, okay, so on page 26, does anybody still need to look at this problem? Okay. And I'll create more problems like this tomorrow, put in a worksheet so that you can get some additional practice with this type of a setup. Okay. But I think once you see it once, you should be able to reproduce it without too much trouble. Okay, so here's 15. Okay, so it says to estimate the height of Milton High School building all the way to the top of the Eagle weather vane, 2 students stand on the front lawn looking up at it. Okay. So one student is behind the other. Okay, Jack looks up with 35-degree angle of elevation. From a point 45 feet closer to the building, Emily looks up with a 51-degree angle of elevation. Find the height of the top of the school. Okay, so we know we're dealing with triangles here. So let's say the top of the building, I'm going to call this M. Okay, so Jack is the one that's further away. So go out here. So his angle of elevation is 35 degrees. Okay, so from where Jack is standing, we're going to move closer, 45 feet closer to the building is where Emily stands. But she's also looking up at the building. Her angle elevation is 51 degrees. Find the height of the top of the school. Let's call this Y. Okay, obviously on the test, you can choose any variable or letter you want to use, but for now, just use the one that I have. Actually, this is not too different from the one that we saw with the mountain and the 100 feet away. Okay, so here's the thing. We do have to involve 2 triangles here to work our way to Y. So our strategy is this. Our strategy is we're going to find a way to get to the hypotenuse, or I'm going to call this H, the hypotenuse of this M, using this triangle here. Right? So I think law of sines should be able to help get us to this h. And once we have h, then we can use SOHCAHTOA to find this y. Right? I think sine will be able to get us there. Okay, so two-step process. Okay, so let's focus our attention on this obtuse triangle here. But first off, everybody good with the diagram? Okay. All right, so focus my attention on this triangle on the right. Okay, what information can we quickly find? Yep. Yeah, that obtuse angle is connected to that 51 degrees. We can quickly find that angle. Good, 129 degrees. Okay, we'll start there. And if we have two angles inside a triangle, we can locate that top angle as well, right? So 180 minus 35 minus 129, what did you guys get? 16. So I think.
You can also find the other angle, which is angle.
Yes, you're right. We could, because we got 90 here, we got 35. We can figure out what that angle is. Yes, and that's perfectly fine as well. For now, I'll leave it out. But yes, we can fill that out. Okay, but right now I'm just going to focus on the triangle on the right. But your strategy works. Good. So now see if you can find h, right? Because I think you're only a law of sines away to solving h. So go ahead and try that. And then once you solve for h, then we can turn our attention to the triangle on the left, because now we have a right triangle after that. Okay, you guys set it up this way. H over sine 35 equals 45 over sine 16. Cross multiply, solve for h. Okay. Questions so far? Good. We're halfway there. Rather than putting everything here, I'm just going to draw the. I'm going to draw the right triangle on the left just over here, so I can just get away from the other distractions that I don't need anymore. So we could find the angle at the top, but I don't think we need it, right? If we just focus on angle 51, what can we use to solve for y? Yep, SOHCAHTOA, right? Which one do we use? Sine, yep. Sine of theta equals opposite over hypotenuse. And then we can use that to solve for y. Okay, how do you guys feel about this? Okay, yeah, so I'll definitely create some more problems similar to this tomorrow, so you can just get more practice, be more comfortable with it, so that when you see it on Friday, you won't have any trouble. Yeah.
So if you did love sign, so that the right answer we would have done on the test would be protocol.
Oh, you use law of signs to get to y. Yep, that works. Yeah.
Okay.
I just decided to focus my attention and use SOHCAHTOA, but yeah, you can do law of signs again to solve for y. That works. Good. Any other questions? Okay, so let's move our way up. Let's look at 14. Okay, so a lamppost tilts towards the sun at a 2-degree angle from the vertical and casts a 25-foot long shadow. The angle from the tip of the shadow to the top of the lamppost is 45 degrees. Find the length of the lamppost. So let's see, here's the sun. We got the lamppost that is slightly tilted towards the sun. And then the light from the sun is going to cast a shadow on the ground. Okay, so the lamppost is slightly tilted. Any idea what this angle is going to be? Good. So we know that the vertical is 90 degrees. We're going to shift it towards the sun. That means it's going to create an obtuse angle. So we do 90 plus 2, 92 degrees. Okay. 25-foot long shadow. Where's the shadow going to be? BC or AC? BC, yeah, it's on the ground, right? It's on the ground, 25 foot. Find the length of the lamppost. So I think, oops, oh, and then the angle, they tell us angle is 45 degrees. Right, the hardest part is just the setup, right? Because once you have a triangle in front of you, then it becomes pretty easy, right? Law of signs. Oh, but we do need to find this upper angle, right? What you guys find there? 43, yeah. Subtract 180. Go ahead. Questions with 14? Okay, read number 13, see if you can create the diagram and then decide what to do with it. Okay, when a hockey player attempts a shot, he is 20 feet from the left post of the goal, and he's 24 feet from the right post. If regulation hockey is 6 feet wide, sorry, my diagram is not drawn to scale here. What's the player's shot angle to the nearest degree? What are we looking for? Angle P, right? But we should, okay, we want to find angle P, but we should start with angle what? L, good, right? So this is a law of cosines. Law of cosines, start with the largest angle. And then once you get that largest angle, you can use law of sines to help you find angle P. Okay, try that. If you get done with 13, go up to number 12. Question? Yes. Yes, I skipped a step there. I subtracted 20 squared and 6 squared all in one go. This is one of the biggest common things that I saw on the quiz again, where a lot of you guys got to this point, you divided out, but you just did not carry that negative over. And without that negative, it really threw off your angle measure. So just be aware of that. That's something that I saw, probably the most common thing that I saw. But again, if you're doing all the other steps right, you're still earning most of the points. It's just that little thing is kind of throwing off some of the other things. Yeah.
Okay. So I have
Okay. Did you do inverse sine?
yes.
Okay. Oh, make sure you're in the degree mode. Right?
I'm in the degree mode.
I'll see. Oh, inverse sine. Oh wait, which one are you doing? Yeah, so I did both. You did both?
Yeah.
So inverse cosine will give you this angle, and once you have that, then you can switch over to law of sines to get that last missing piece.
But it won't give me that. I tried something. And it gives me.
So you have negative 0.58. You want to do inverse cosine of negative 0.58.
Yeah, I do put sine first.
No.
And then-
Oh, so okay. So you want to do cosine of it first, right? So take care of the top portion. Get that angle L first, and then you can move on to sine.
Yeah, yeah, so. I clear everything.
Oh. So do inverse cosine, negative 0.563.
And that gives me yeah.
Okay, good.
And then I do
Inverse cosine.
inverse cosine.
Yeah, that should work now. There, okay, good. Okay, questions here? Okay, look at number 12. Draw your triangle and see if you can convince yourself whether you have 0 triangle, 1 triangle, or 2 triangles. Okay, any questions with number 13? Okay, look at number 12. Okay, here's number 12. Number 12 is a side-side angle. There's that hanging side that we have to figure out the height so we know what to do with that 9. Sine 58 equals h over 14. We saw for h is 11. That 9 is too short. It's never going to find a way to connect to the other side or the opposite side, so no triangle. Yes. Okay. Okay. Any questions? Yeah. I'm sorry? Test is Friday. Test is Friday. Yeah. So I have 4 problems for us to do for classwork. Just review from, so I have a potentially a ambiguous case problem, and then we have a couple of area problems just for us to practice with. Okay, so 4 problems. You guys should get this done in class. If not, at least get through 8 and 9, and then we can finish the rest tomorrow. Okay, so go ahead and do that. And that way tomorrow we can focus our attention on just getting some more practice with more problems. Yeah, so class for page 24 to 25, 8 through 11. And when you get through, when you get to 9 to 11, I accidentally cut off the directions there, but 9 through 11, you're just finding the area. But for 8, you're solving the triangle like as if it were a quiz question. Go ahead and use the space for number 7 as you go through number 8 if you like, since this might be a longer problem. Okay, I'm working through number 8 right now. Here's the progress so far. Oh yeah, you go to page 25 and do 9 through 11. So 8 through 11. And 9 through 11 are just area problems. Yeah, 9 through 11. You see the very bottom of the below number 8. It says find the area of each. So it got cut off. So yeah, these are area problems. Yep, go ahead.
You say for 9, find the area or solve it
Find the area.
for all 3.
All 3, yeah. 9 through 11, they're all area problems.
Do we find the area for this one?
Yes, area for all, yeah, for 9 through 11.
But what if it's not like SAS or SSS?
Then we have to use law of sines to get it into,
Oh, okay.
right, yeah. So number 11, it's not side angle side, so we got to do law of sines to get it into side angle side. Guys, even if you're not finished, just show me your progress on page 24 and 25. I'll just give you class credit.
25 of that.
Okay, yeah.
I can help you with that.
I did it differently when I was doing the 34. That's, and I was like,
Oh, you're good. You're good.
That's,
Okay, so tomorrow I'll give back your quiz. I have a worksheet for you, just word problems, and then should be ready for Friday's test.
no.